Okay, here is the video guide for lesson 213, more angles formed by transversals. So we talked about this a little bit in 212, when we have parallel lines getting cut by what we call the transversal, we get different relationships that form out of it. The one we saw in 212 was the corresponding angles. Okay, so we're going to move on and we're going to look at more of those. The first question is asking us, out of the relationships that we've talked about so far, which of those always have congruent angles? Okay, and for us, the two that we've talked about so far, out of supplementary, complementary, corresponding, and vertical, the two that have the congruency would be our corresponding right here. Corresponding, again, is this idea that if you have these parallel lines cut by a transversal, these angles that are in the same location, just on two different lines here, those are our corresponding, so that would be one of them. And the other would be what we have as our vertical angles. And vertical angles are like our 1 and our 3, or the 2 and the 4 here. And so those are the two. I don't usually love giving away answers, but those ones are good to be good vocabulary work there and remember what those means and the qualities that they have. Okay? As we move on here, we get to look at this shape here. And we have to say, like, considering what's happening, which is pretty much a shape, an isosceles triangle formed off of reflection, what pieces of this triangle are congruent? And we can see that side AB is congruent, and I can't use my sign, my congruency sign, to side BC, and that would be one thing. Okay, there's more, and I would say really focus on which angles in here are going to be congruent. Here we get into this idea where we get parallel lines cut by a transversal. You know about vertical angles and corresponding and supplementary. So can we find B if we know A is 48? Okay, and the way I like to think about it is like, well, B is corresponding to some angle up here, and then you can use vertical angles to figure out just what it's going to be. Okay, so do what you can, figure out what B would be. This is just a short reading one. That way I'll skip over, that's just somebody's explanation in terms like of the book or the way that they're trying to explain it. Here we have to say, well, are these going to be always congruent? Are these going to always be supplementary? And then you're going to have to click one of the two and then explain your reasoning of how you know what's congruent or how you know what's supplementary. For example, if you believe these are supplementary, I would say, well, B slides up and A and B form a straight line, so I know that that must be a supplementary relationship. Or if you think it's congruent, say, well, B slides up where it's corresponding, and then becomes vertical angles there, and vertical angles are always congruent. Same for here, and I've had people say, these look like the same problem, but they're not. So you can see where A and B are located here versus where they're located here on the outside, and you need to say, is that congruent or supplementary? Another one. Again, A and B in different locations here. Are they congruent or supplementary? And you're going to have to explain each one. Here, we get to highlight the big vocab word of the day, which is alternate interior angle. Okay? So they're saying here that this angle BCF and this angle GFC, these two gray angles, are alternate interior because they're inside the parallel lines and on alternate sides of the transversal. One more time, they're inside the parallel lines on alternate side of the transversal. And then it's asking us, can we find another one? And so we got to make sure we use that 3-lettered method. Can we find another pair of alternate interior angles? I know that there's another one in there. Here we have a conjecture or a conditional statement saying if the lines are parallel, then the alternate interior angles are, and we just have to finish, are what? They're always going to be this. They're sometimes going to be this. They are what? Okay. Here, just another quick vocab, not the most important vocab, but quick nonetheless. Back here, it is an if lines are parallel, then alternate interior angles are. And here, they're doing the same thing, but using an arrow diagram. So it's the same thing. The first thing needs to happen for the second thing to happen, and that's the same thing as my conditional statement here. Okay? So when it's saying what does the arrow diagram mean? Well, it means what a conditional statement means. It needs a first thing to happen so that the second thing is true, or the first thing to be true so then the second thing is true. Okay? The last thing is just proving using rigid transformations that these are that you can have them land on top of each other, and I think we're going to be able to do that. Now we get to the other key vocab of the day. Instead of alternate interior, we have same side interior, okay? And you can tell the difference here. Alternate, one's on the left, one's on the right. Here, same side, they're both here on the right, okay? You just have to say, why do you think that they're called that? And remember, interior means inside the parallel lines. Same side of the transversal, okay? What is the relationship between the angle measures? That's for you to find out. Are they going to be congruent, like we saw with alternate interior? Are they going to be supplementary? What are they going to be, okay? And then we can write this conjecture like they have down here. If lines are parallel, then same side interior angles are, well, congruent, supplementary, or something else. Okay? Here we can just take it a little bit further, trying to explain, is this right? A plus B equal 180 if A equals C, and just explaining what's happening here, and if we can come up with concrete, yes, that's always going to be the case. And then lastly, we have just a light diagram. So you can see a light source shining a beam. It's reflecting off of that mirror, and we get these different angle relationships. What I'm going to say is, if you look at like C and D, think about the reflections that we were doing in class in Chapter 1. Is there reflection symmetry here where we can say, well, yes, one angle is the same as the other because of the reflection? Okay, and that's going to be the same in all these. Then this one is C and E. Maybe that one's more or less a relationship that we've talked about, an angle relationship we've talked about. And then the last one is E and D in this diagram, and how can we be sure if there is a relationship there? And then we are just wrapping it up here with A through C, proving that all the measures, and what that really means to us. Okay? If you have questions throughout it, some of that I went by quick, especially this last problem here, please just be sure to reach out, and I'm happy to make individualized videos.